There are three things I wanted to spend some time on. One is regarding the second project, and the other two are regarding the drawing program, which we are discussing this week, and we also discussed that last week, right? So, regarding the project, some of you have been asking me whether your states are correct, your events are correct, etc. I think at some point I had said that you would know it when you uh, get it right. But I am also aware that you have not experienced that this process of finding states and events and coming up with state transition tables before, so you wouldn't really know how that feels. So let me give you another way of figuring out whether your work is correct. So let me share the screen here. So this is a fairly good approach to finding whether the state transition table or diagram, which is equivalent, is correct, which you can employ to check your work. All right, let's look at this state transition diagram. The reason I am showing this is because or I could try the other one, state transition table. Let me see if I can rotate it. If I can rotate this, I will use this. Otherwise, I will. I don't have the PDF reader here. I mean, this is my PDF reader. It's not all that great. I don't have the Adobe version. Okay, I'm going to go to the diagram. I am not sure how to rotate this. So this is just as good. So, of course, this diagram, I believe, is correct. But how would you check your diagram? How would you know if that is the right set of transitions? One way would be to come up with sequences of events. You come up with one sequence, then you come up with a second sequence. Come up with as many sequences as possible, okay? And what you should do is imagine the system to be in some state. For example, assume that we are in the cooking state, and then we assume that we get a cook button push, then the door is opened, then the door is closed, then the timer ticks a few times. What happens in the diagram and what should really happen? So if you are in the cooking state, and if the first event is door open, if the first event is cook, if you press the cook again, it should continue cooking, adding 1 more minute. So it should remain in the cooking state, and 1 more minute will be added. Now, if you open the door, cooking will end. If you close the door will be closed. And if you have the timer tick a few times, nothing is going to happen. The door will be closed. So if I wrote or if I drew a diagram like this, what I should do is see whether the door will be closed after this sequence of events. So I will assume that I am in the cooking state, and I see what I have drawn, how I am processing cook. I see that I am remaining in the same state for cook. Okay, so that is the first event. Then I said the second event is door opened. So if the door is opened, this says I will go to the interrupted state. Fine. Then I said the third event is door closed. So I will go to the door closed state. And if the timer ticks, I remain in this state. So at least for this sequence, what I thought or what I had concluded to be the final state is the same that the state transition table is giving or diagram is giving me. So it works out. But that is not a definitive answer. You try more and more sequences. and assume that your states are different in many of these. And you keep trying and then see whether there is any bug in your state transition table or diagram. That would be a pretty good way of checking whether your work is correct. The second thing is, do not combine events. What I mean is this. If you look at events in the microwave, you have things like timer ticking, door closing, door opening, pressing the cook button, etc. Don't take two of these events and then say, I will process them together. One student had asked me a question about this. That student was proposing to use two events in the security system in project 2 and then said, I will process them together. That is a recipe for a very messy implementation. You might find it easy to write your or draw your state transition diagram, but implementation is going to be very painful. If you have two events, you need to remember those events. You need to see what happens with each of those events. You can't club them together, right? That would be a big mistake, in my opinion. Are there any questions about this or anything related to group project 2? All right. If you don't have any,
I have a quick question. Sorry.
Oh, yeah.
So for, you said you shouldn't have the events overlapping each other and processing them at the same time. But if you have states that are functioning basically the same, it just matters what event triggered that state. Is it possible to use a field, like a static field, to keep track of what started that state so that you could minimize the number of states, or is it better with object-oriented design?
You shouldn't try to remember why you came to that state. A state means there is already an associated I mean, I don't know. I don't know how to phrase the sentence without using state again. So the fact that you are in a certain state means the system is doing something. How you got there is not all that important. It is because what is going to govern the functioning of the system, or what is going to determine the functioning of the system, are future events. So you shouldn't have to remember how you got there. The state itself should be sufficient. But in some cases, you might want to have the support of the context to remember things. For example, if you are cooking in the microwave and you have 500 seconds, you don't want to have 500 states to say one state is like 1 second remaining, another state is 2 seconds remaining. That is ridiculous, right? That is why we have a cooking time left field. And then you keep decrementing it. Otherwise, there is no way to, I can't think of a way to solve it without having the timer keeping track of the time. You don't want to have an infinite number of states at that point. Okay.
Right. Thank you.
Or another example would be a thermostat. If you have the room temperature at possibly 100, or many different possibilities in Minnesota, I suppose it could go from -50 to plus 100, right? Or whatever. So you don't want 150 states for 150 different temperatures. At that point, you probably say, I will have a temperature field to remember that.
Yeah. Well, the specific case is there's an instance in the business class or in the specifications where if a certain event happens,
Mhm.
depending upon the state you're currently in, it might go back to that state at
Yes,
timeout.
yes, of course.
So
Yes,
we
yes.
just had it go into two different states to solve that.
Oh, okay. Yeah, some cases you will have to have conditionals. I mean, it would be very difficult to program without conditionals in some cases in this particular assignment, I think, unlike the microwave. So if you find occasionally having a conditional, don't despair. I think it is going to be probably quite hard to remember to do it in a different way. But there are certain things that you can certainly avoid.
No, thanks for addressing that.
Okay, okay. Any other questions? Okay, the other two things that I want to discuss are related to the drawing program. Okay, so let me share the screen to a different window here. Okay. I'm looking for that window. I can't find it. There's so many windows open here in my system. Okay, here you go. All right. I think maybe I mentioned this, definitely a few students noted this. On Windows, if I click the polygon button and click various vertices, and when I have finished clicking the last vertex and hit the return key, on Windows, it doesn't close the polygon. The reason is that when I press these, or rather, when I have any event like clicking a button or clicking the mouse or pressing the escape key, pressing backspace, any event that you generate as a user, the windowing system has a particular focus. There is a particular agent to which that event is sent. So for example, when I click here, it is going to the canvas. Okay. When I hit the enter key, it is going to the canvas. That is on Mac. But on Windows, when I hit the enter key, it goes to the buttons. I read Java documentation on this. They shrug their shoulders. They say the windowing system is different on different platforms, and there is no telling who the recipient of that event is going to be. So what works on Mac doesn't quite work on Windows. There is nothing, I mean, there is something that you can do in Java programming, but I didn't find anything that is simple and elegant. I could fix it, but it is a very dirty solution. What I did was I said, when you click the polygon button, I will request that the focus now be given to the canvas, the drawing panel where the canvas is, so that even the enter key is going to be delivered here and not to the buttons. In Windows, you can actually see this. When you hit the enter key, you can see the button kind of flickering, the polygon button flickering, because that is the focus of the pressing of the enter key for whatever reason. Whereas that is not the case in Mac. It is seemed to go directly to the place where the I don't know what the algorithm is. Okay, I plead ignorance here. But what works? This is not my discovery. It was a student who discovered this. What you can do as a user on Windows is press Control and hit Enter. Then the event gets delivered to this plot of the screen. So instead of pressing Enter, press Control Enter on Windows. That seems to work. I mean, I don't know what I can do. What else I can do about this? So it is it is difference. It is the difference between various systems, that is causing the problem. But the but if you have provide documentation with this, you should write probably, or I should write probably that on Windows you have to press Control Enter, not Enter. That is because that is how it is behaving. Okay. And another moral of the story is that you should test your program on all systems. Yeah, I assume that since it is Java, it will work on all on all platforms where Java is implemented. But that is not the case. You live and learn, I suppose. Okay. The third thing I want to do is actually go through the drawing program and tell you what all you have to do to add a new shape to the system. This is important because in the third exam, there will be a question on that topic. You will be asked to add a new shape and you will have to implement the complete functionality. I'll be giving you a handout next week as to what is going to be on the third exam, the nature of questions, etc. But let me tell you ahead of time that there will be a question that asks you to add a new shape. So it is a good idea to see what you have to modify. So let me show you that. Okay. I'm going to now share the Eclipse window. Let me collapse a few things here. All right. Okay. Here is on the left side is the project, class project 3 version 1. It has 4 packages, not counting application, model view controller and the GUI package, which I call the physical layer of this whole thing because it is so close to the windowing system that I don't want to call it a logical thing. Okay, controller model and view are independent of the technology that is used. If you want to add a new shape and make it consistent with what is already designed and implemented, you have to have a new button. Suppose you want to add a triangle, then you have to have a button for creating triangles. So you need to go to GUI and the inputs to the graphical user interface go through the controller. So look at the controller and there is a package here called buttons and you need to add a new button like what you have here. So you would probably copy the stuff in Polygon button and then create a triangle button. That is one thing. The second thing is you need to generate an event for this. So that event would be under controller. For every shape, there is there is a corresponding event. So for example, when a polygon is created, there is a create polygon event. When a line is created, a create line event captures that. So you need an event. The third thing is for every event except for a couple, there is a method here. So for example, when I create a label, there is this handle event method which handles that event. So when you create a triangle, there will be a method to handle that. So you should have one more method here. No new class, but one more method. The moment you put in a method into controller, which is an interface, you are going to get a syntax error in drawing context because drawing context claims to implement controller. So if you add a method to controller, you have to go and put in a new method here, and that would be more like this. Any of these actually, like public void handle event, create polygon event, you ask the current state to handle it. That's it. So it is a copy and paste, and it takes maybe 1 minute to complete that. Then, of course, if you do that, you will get a syntax error in this because there is no handle event for create triangle in drawing state. So you need to put in a method here to handle the triangle drawing state, triangle drawing event. I'm sorry. So you need to have one event, one method for that. So look at the code for similar functionality and see what happens. For example, when you create a polygon, the method is empty. So you should look at quiescent state and see what is done for create a polygon event. It tells, tells the drawing context to change the state to polygon drawing state. So you'll have a triangle drawing state, and that is going to be uh, generating a syntax error over here, which means you need to go to control commands controller.states package, the same package that is, and create a new state like polygon drawing state. But a triangle doesn't have that much complexity as a polygon, so it would be a different class altogether. So you will have something similar to this, but a triangle only handles points, point inputs. It doesn't really need this confirm event. And here, when you try this, you will see that you'll be creating a command and so on, which means you need a command class for this new shape, which is a triangle. So you take something like a polygon command and then copy it as a triangle command and adjust things, which means you'll have a triangle shape, which is going to create a syntax error. And then you need to add that to the model. Model.shapes has one class for every shape. So you could probably take the polygon and then adjust things as you see fit to accommodate a triangle. And surprisingly, that is all you need to do. You don't really need to modify anything in the undo manager. You don't have to change anything in the renderers, nothing. You don't have to change anything in the view because the system is so decoupled and so cohesive that you don't have to worry about anything in view You don't have to change anything in model.java. You don't have to worry about these handlers. All those mouse clicks will be delivered to properly to this new shape when that shape is in progress, etc. So it is, in summary, the process of adding a new shape is very well defined. It is not the case that you have to go and update all kinds of places. You need a new button, you need a new event, you need to update the controller interface to handle the new event, which means changing the drawing context to add that method, drawing state to add that method. The probably the only non-obvious case is the quiescent state, because you'll be drawing a triangle in the quiescent state. So you need one method, you need to override the handle event method over there. That is not immediately obvious. But if you don't do it, then nothing will get drawn. I mean, when you click the triangle, nothing will, the triangle button, nothing will happen, because somebody has to actually do some stuff when that button is clicked. So that is in the quiescent state. And once you put that thing in the quiescent state, again, it triggers a series of changes. It means that you have to create the triangle drawing state. You have to go to the command and then create a command for it, which means creating a shape. And that is the end of the changes. So I would suggest that you practice modifying this to add a new triangle. And it is a requirement that whatever shape I ask you to implement should be implemented without relying on any other shape being in the system. So you can't assume that a line can be drawn or a polygon can be drawn, that there is a command to draw a line or a command to draw a polygon. You can't put some code in polygon and then say, well, if it is a triangle, just do 3 sides, That is going to fetch you almost no points. It has to be a completely independent shape. Okay. Questions? All right. If you don't have any questions, let me stop recording here, and I will make I'll make the class exercise available and then create the breakout rooms.